All right, well, good morning, everybody. How are we doing today? Okay, so I have attempted to make a couple changes just to make it easier for me. So hopefully I have it to where if you type a chat, I'll be able to see it without having to walk over to the screen. So if you have a question, just put it to the chat. You can either, ask it with everybody or just ask it to me. I'll probably read the question and then answer it anyway. And looking at chapter 18, we are going to have a quiz over that on Friday. That's going to be multiple choice. There are a couple thermodynamics questions in the take-home exam. So that is how we're going to evaluate chapter 18. I don't think the test is going to be that long, your quiz on Friday, but I am going to open it at 9:50 if you want to start a few minutes early and get a little extra time on it. So you'll have from 9:50 to 10:25 to take that quiz. If you have a problem with that time, I expect you to contact me ahead of time and we will arrange something. Okay, other than that, you will be taking the quiz the same time as the rest of the class. Now, that is going to be open book. So you're welcome to have your book, welcome to have your notes while you're working on that. That being said, I expect you to read the questions well. I am not trying to throw trick questions at you, although there might be one or two that are tricky. They're not intended to be trick questions, just something you need to work on. And somebody asked, well, what kind of questions would be possible types of multiple choice questions that we could ask out of chapter 18? And looking at it, look, say, for example, out of your textbook, there's a couple problems that I think would be good type of multiple choice preparation, and that's 24, because it asks, it's going to be entropy favored. Do we expect to see an increase in entropy, a decrease in entropy? A couple other questions that would be examples are later in the chapter in the summary and conceptual questions. If I can get to that. So at 74, what is the sign of each of the following? Delta H, delta S, delta G, or it could be some combination of those. Or I could ask, a reaction, I would give you a reaction and you might actually be expected to calculate delta G. So you will need the table in the back of the book for the quiz, okay? So if you don't have the thermodynamics table, the quiz is going to be really difficult for you. So make sure you have that available, okay? That's going to be one of the most important parts. Yes, you're going to have to calculate a couple things. For the most part, there won't be, but I might say, the reaction, some reaction up here in A, spontaneous, because delta G is greater than 0. B would be the same thing because delta G is less than 0. C would be non-spontaneous. Because delta G is greater than 0, and non-spontaneous because delta G is less than 0. Okay, so immediately you should be able to figure out that only reactions that are spontaneous, they all have a delta G of less than 0. So we can eliminate A, and if delta G is less than 0, it's not going to be non-spontaneous. So then we just have to figure out if delta G is going to be a positive or a negative value. So that would be an example of a type of multiple choice question I might ask. Okay. I might actually ask for a calculation or two. And I was debating about what day to make the due date for the chapter 18 homework. We're going to have the quiz on Friday. I would expect you to try to complete the homework by then, but I am going to make the homework for chapter 18 due Monday. So Monday at the end of the day, the chapter 18 homework is going to be due. I will post at some point which problems I'm going to grade, and you should just be able to add those. Now, hopefully I've got it set up. Hopefully I had chapter 17 and 22 set up to where you can submit multiple answers for that. So if you need to take a picture of each one and just submit those, you can do that. Hopefully I will get that set for this one as well. That's my plan. I do plan on having chapter 17 and 22 problems graded by the end of the week. I'm still trying to get figured out how I'm doing everything, but I've got some of them graded. I don't have them all graded. If you don't have those in, if they're in before I start grading them, I won't count them as late, okay? If I start grading and it's not in, I am going to count it as late, and that's going to be half credit if they're turned in late. So get them in if you don't have them turned in yet. And again, Monday, end of the day, chapters 18 questions are going to be due. There's going to be 4 of them that I'll collect, and I'll post that probably on Friday, which 4 of those are going to be. In the meantime, you might want to do a lot of the homework to prepare for that. So be that as it is, if you have started the chapter 18 homework and you have questions, I've set a little bit of time aside now so I can answer questions. So if there's one that you have a question about, go ahead and just type its number in the chat and I'll take a look at it. And if there's no questions, I will go ahead and move on. So I'll give you a minute to decide here. Just for those who are on camera, give me a, yes, I've got most of the homework done. I've started it, but I really haven't done a lot with it, or I haven't started it yet. Okay, so good. A lot of you are somewhere in the middle, which is probably where you should be. Okay. All right, so I don't see any questions over chapter 18 problems. Oh, the question is the quiz online where we answer by typing it out or clicking the correct answer? Or is a quiz a Word document that we either printed or copy down on paper and take a picture of and upload like our assignments? Okay, this quiz, now, all quizzes and this quiz are not the same, okay? This quiz will be all multiple choice. It is gonna be on Canvas, and you're just gonna click the correct answer. And at the end, I haven't done a quiz on Canvas like I am planning on doing, so hopefully I'll have it figured out by Friday. But you should just be able to click the answers. You should be able to go back and change them, and at the end, you'll hit submit. That's how I'm intending to set it up. If something goes wonky, then I'll figure that out at the time. So I will be right here on Friday. I will start the question for the lab at 10:25, which is when you should be done with that. So I'll have a Zoom starting at that point. If you have questions, just shoot me an email. I'll be standing right here ready to answer with that, ready to deal with it. If I need to go into Canvas and adjust something, I will be ready to do that right then and there. Okay, so now on a couple of the tests, when we get to the chapter 19 test, we're gonna have, actually I've decided I'm gonna do a multiple choice quiz with 19 and 25 and a problem quiz for 19 and 25. I don't know exactly how I'm gonna set those up day by day, depends on where we are in the class. But on the problem one, you'll actually take pictures of it. You'll write down your solution and you'll take pictures of it and submit that. So that's how we're going to do that one. And it will have that. The quiz and the question is, the quiz ends at 10:25 a.m. Yes. Okay, so you will have 25 minutes. Actually, I'm going to start it at 9:50. So you'll actually have a little extra time if you want to use it for the quiz. Okay. All right. So seeing no additional questions, I do want to go through a little bit more of the entropy. And I want to review, so I have it on film. the molecular view of entropy that we started out with this semester. Okay. And your book goes into a big deal about talking about entropy as disorder. And if you looked at my PowerPoint, I used the PowerPoint for the book. The publisher provides a PowerPoint for it, but I edited it quite a bit before I posted that. They talk about entropy as disorder, but a better view of entropy is looking at the number of microstates. Okay. And somebody says, can they ask a lab question? Yes, you can ask a lab question. I will answer it after I go through the entropy thing here. Okay. So if I look at something, now the original one I did, as I said, let's say we have a system that has only two possible states. They're connected, but we'll ignore the connecting apparatus. And if I have a molecule, it can either be here or it could be here. Okay. So there are two possibilities to it. So we've got that. What if I had something that had four possibilities? Okay. Well, I could have one here, I could have one here, I could have one here, or I could have one here. Now, the probability of the one being in here is going to be 1 in 4. Okay. What if I have two? Okay. Well, then I've got a whole bunch of different arrangements that I could have. Okay. I could have both of them in here. I could have one in here, or I could have none in here. Okay, now if both of them are in here, none are here, none are here, and none are here. If one's here, I could have one here, okay? Or I could have one here, or I could have one here. And if we look at it, we see that the odds of them both being here are 1/4 squared. There's 16 different possibilities that we're going to come up with. So we can see that it becomes more complicated. Now, when I start looking at whether they are the same or different, if I could have A and B here, I'm actually going to have a lot more possibilities if I have distinguishable particles. Okay, so in a situation like this, the entropy of a mixture is going to be much greater than that. And if we look at a distribution, and I'm just going to draw a couple roughs because I have, well, you guys know my artistic ability by now. It's so great. Okay. But if I want to take a look at the probability, we'll put the probability here. Okay. And we look at the particular arrangements. So let's say that just with the two particles, I have, you know, one particle here, one particle here. If we look at the distribution, I'm not going to worry about what this axis is. Think of the number of particles in the arrangements. If I were to graph the air molecules in this room, I would find that even though there is one possibility where all of the air molecules in this room would be inside my coffee cup, that's not very probable. As a matter of fact, its probability is so small, my calculator or even my computer won't give me a probability that small. Okay. The number would be huge. It would be on the order of a Google to the Google power to the Google power. Okay. We're talking about a very small probability there. So when I look at it, we find that there is only a simple peak with the number of probable outcomes, and that is a relatively even distribution of the air molecules in the room. This is how entropy helps us to understand the way things are probably arranged. And these are the only probable arrangements that we're going to find. We're not going to have half the air molecules on this side and the other half of the air molecules in my coffee cup either. That's going to give you a very low probability. Okay, so that's the low probability. All right. So the other thing, my kids were actually watching something about the universe and everything, and one of the things they talked about was the heat death of the universe, because if energy is always converted into entropy, won't eventually all of the energy in the universe be converted into entropy? And theoretically, that is one of the possibilities. Whenever you hear somebody talking about the heat death of the universe, when all of the energy goes into entropy, then that's the situation we have. We have just pure disorder that's going to be at that point. So eventually, in a few trillion years, the universe is going to be like that. Now, that's only one theory, okay? There's another theory that says that there is gravity, and gravity is an entropy. There's all kinds of theories out there. But we'll look at, we're not going to go into cosmology or anything like that. I just thought I would mention that because somebody had asked about that. So the probability distribution is something that's going to be important, even though we're not going to actually be tested over that or anything. I just wanted to make sure you were aware of that. And let's see, one more thing. This equation, delta G is equal to delta H minus T delta S. Okay, when we look at this, the Gibbs free energy that we have here, we take a look at the entropy and enthalpy and their contribution to it. If I have a negative enthalpy and a positive entropy, that reaction is going to be spontaneous at all temperatures, okay? If I have one that is positive delta H and a negative delta S, it will never be spontaneous at any temperature. Wow, that sounds like the good setup for a multiple choice question for a quiz, doesn't it? Okay. So what happens then if I have both of them positive? Okay. Well, in this case, if the temperature is low, this term will be small. Okay. So if this term is smaller, then delta G is going to be positive. If it's larger than this term, then delta G will be negative. So at high temperature, that's going to be spontaneous. So that's an easy way to look at this reaction. And the big thing in this entire chapter is using free energy to determine whether something is going to occur spontaneously or not. So, and what's interesting is if there are things that are going to be spontaneous at certain temperatures that are not at other temperatures. And I'm not going to go into it right now, but there's a lot of biological implications to the free energy that's involved. So at certain temperatures, ATP going to ADP is not in a favored reaction. Okay, it's kind of an interesting thing, but you'll see that if you get onto biochemistry and some things like that, you'll look at those reactions. All right, now somebody asked if they could ask a lab question. So the question appears really big and I can read it, but I can't see who it's from, so don't worry about that. So somebody asked if they could ask a lab question now. So I'm waiting for the lab question to be typed here. And while I'm at it, were you all able to find the lab and the information for the lab on Canvas? I have to apologize. The very first time when I put it on there, I don't know what happened. The links to the YouTube videos didn't work. While we're at it, I would like to thank our 2 stars, Zoe and Hannah. You just sent me that. I'm like, oh, that is perfect. Okay. Oh, by the way, what does the minus sign do to this equation? Okay, this, let me find a marker that works. This minus sign right here, I am assuming is what you're referring to, okay? And when I look at this, if delta G is less than 0, or in other words, we're looking to see whether delta G is going to be negative. If delta G is negative, we have a spontaneous reaction. So we know that an increase in entropy tends to be something that will occur spontaneously. So if I have an increase in entropy, then that would indicate more towards spontaneity. So that's why this term is negative here. Delta H, we know a negative value of delta H is exothermic. Okay. And then let's see. From the lab, how do you find delta G? So I'm going to switch gears here. And we're still going to use the same equation a little bit, but there's some other equations that we're going to work with. And I didn't spend a lot of time on those because I was expecting answered questions. But again, I see that from the lab. Okay. So there's really two equations that we need for the lab. Okay. And the first one is based from this equation. That's a natural logarithm. I can't draw today either. At least not on the top of the board. Delta G is equal to delta G naught minus RT ln Q. But if we're at equilibrium, this is 0 and this is K. So delta G, I've rearranged this equation, naught is equal to negative RT ln K. We found the KSP in the KSP lab. That is the K that we're referring to, okay? So delta G is negative RT ln K. We're going to repeat this, and this was probably around 295 Kelvin, whatever the temperature of the room was when you did this. Hopefully you measured it. If not, you're going to have to go back and look in your book and see what temperature the lab normally is, and you'll have to like say, mea culpa, I forgot to record the temperature. But hopefully you recorded the temperature that week. Okay, now with the data that I posted for Canvas, we're going to do this at 373 Kelvin, and we're going to do the same thing. Delta G is equal to RT ln K. And yes, we're using hydrochloric acid and the calcium hydroxide. The moles of acid that we have in the titration are going to be the moles of hydroxide present in the titration sample. Okay, so hopefully that answers those questions on the lab. Do I have any other lab questions on that? I'll go through them a little bit more. And then remember, when we go through this equation, this is going to give us delta G. Well, here, let me underline it in a different color. This is going to give us delta G. Okay, that marker doesn't work. We'll use this one. Delta G and T at two different temperatures. Now, if we really wanted to do this well, we would do it at a third temperature, because what we're going to do is we're going to plot a straight line based on this equation. Using the y equals mx plus b. And if I do that, if I have 2 points, I'm guaranteed to have a perfectly straight line. We're going to do it with 2 points anyway. Okay. To find the original sample, do you divide the moles of hydroxide by the volume? Yes, the volume is 10 milliliters or 0.01 liters. And that's going to give you your hydroxide concentration. The dividing the mole by hydroxide by 2 is going to give you the calcium. Yes. And can I try problem 16? Yes, I can do problem 16. Okay. Let me start by looking at problem 16. Then I'm going to read through it for everybody in case you don't have your book open. All right. Using values of delta H and delta S, calculate delta G for each of the reactions at 25 degrees Celsius. Okay, why is 25 degrees Celsius important? First of all, we have the temperature. Second of all, that is the standard temperature where all these are done. So I was asked about 16. I'm only going to do one of these two. So let me go ahead and take a look at A. Now, in order to do this, we're going to have to do some looking in the back of the book. So I will do that. I also brought my handy dandy calculator today. I had it here the other day too, but I forgot it because I buried it under a bunch of books. I know you guys who have seen my desk in my office, or at least seen the stuff on my desk in the office, are not surprised that I had a bunch of stuff all over my calculator. All right, so let's take a look at A, which is 2 sodiums. Kind of fishy, isn't it? Tuna. I know, I told that joke in Gen Chem 1 and you guys gave me the same looks when I did that. Okay, all right. 2Na plus 2H2O, this is a solid. And that's, water is a liquid. That's kind of important there because enthalpy and entropy are state functions. If we don't know what state they're in, we can't figure that out. And that's going to be important. And that's going to give us 2 sodium hydroxide. And the sodium hydroxide should be aqueous, yes. Now, again, your book is going to put aqueous. If I don't put a sign there, it's going to be aqueous. So in order to do this, we're going to need to find delta H and delta S. So delta H is going to be delta H of the products, sodium hydroxide, hydrogen minus reactants. So I get to turn to the back of the book here. And I'm going to do something before I do this. I'm actually going to list, well, let me do delta H first. Delta H and delta S for each of these, and then I will put them into the equation. So when I'm looking them up, I can just write them down here. This is how I do it. It just makes it a little simpler. And then I can look on here. And let's start with what I can find. Okay. Let's start with sodium. Now, I know that sodium solid is going to have a delta H of 0 because it's an element in its standard state. Likewise, I know hydrogen gas is going to have an enthalpy of 0. However, the entropies are not going to be 0 for those. So sodium's entropy at 298 Kelvin is 51.21. Okay, and then sodium hydroxide, aqueous, the enthalpy of formation is negative 407.27. And the entropy is 64.46. Do this right. Okay, now I need to look up water and hydrogen. So the A32 was the page where I found the sodium values in the sodium hydroxide. To find the water and the hydrogen, I need to go back a couple pages to A29. And again, looking here, wow, not surprising at all, the value 0 is present for the enthalpy of formation of hydrogen, but the entropy is 130.7.
Professor Oberly?
Yes.
You have the wrong delta H for NaOH. You wrote down the sodium chloride.
I wrote down sodium chloride. Okay, what is that value?
It's negative 469.15.
Thank you. I worried about the lighting so that you could see the board without any nice glares and everything like that. But then I forgot to take into account that I need to read my textbook. So keep track of it for me. All right. And then H2O as a liquid, negative 285.83. And the entropy for that is 69.95. Okay, So just something interesting here before I move on. Notice that I have something here. This is a solid. Its entropy is 51. Okay. Here I have a liquid. Its entropy is about 70, so has a significant increase. Plus, I've gone from a atom to molecule. But if I go to a gas, even a gaseous element, I have an incredible increase in the entropy. So that's something that you might be aware of as well. Now, in order to find this, we are going to go ahead and take delta H of the products minus delta H of the reactants. Now, as we're doing this, these things are important. We have to take them into account. Okay, so when I do this, I'm going to have 2 times negative 469.15, and this is in kilojoules per mole. I'll put the kilojoules per mole there at the end. Okay, plus for delta H plus 0. I'm going to go ahead and write the plus 0. I'm okay if you don't do that, but to help you keep track of things, I'm going to write that in there. And I'm going to subtract the values for the reactants, which this is going to be 0 plus, again, 2 times negative 285.83. Okay, and this is going to give me a value of delta H, and I'm going to let you calculate it and double check my work here. And I end up with a value of negative 366.64 kilojoules per mole. If I did it right. If I didn't do it right, then a bunch of you will say, no, that wasn't it. Okay, hopefully. But either way, this is just punching buttons here. I'm going to repeat the same thing with the entropy. Okay, so the delta S. Now this is going to be a little bit trickier because I have values for each one. So for sodium hydroxide, I've got 2 times 64.46 plus 130.7 minus, again, I'm minusing all of the product or of the reactants. So this is going to be 2 times 51.21 plus 2 times 69.95. And let's calculate here.
You also have the wrong delta S value for NaOH.
Uh-oh. What is that supposed to be?
48.1.
48.1?
Yeah, you wrote down the solid state.
Okay. So, yeah, it's real easy to mess up on that stuff, isn't it? Okay. All right. So, doing this then, I'm going to clear that since I put the wrong number in there. Okay. And if you do this wrong and it comes up with an error, you know you messed up on your parentheses. So let me try this again. So I'm going to just simplify it a little bit. This is 226.9 minus So this gives me if I did that right. 22.06. Okay, that might be correct. Let me redo this here. So let's see if I got these numbers right. Okay, yeah, I came up with this one here. All right, and somebody asked here, just a second here. Okay, so in each of these, our units are joules per Kelvin mole. So our answer is going to be in joules per Kelvin mole. This is in kilojoules per mole. This is in joules per Kelvin mole. Okay. Now I'm going to take these two values and I'm going to erase this up here just because I don't have enough board space in there. I would just move on here. Fortunately, this is I'm hopefully recording this if I didn't mess up like I did Monday. I intended to record Monday's lecture and did something wrong, so it's not recorded. If I do this right, it will be posted later today. Okay. So here I am going to do delta G is equal to delta H minus T delta S. So this is delta H and we have to remember the temperature. Now, fortunately, in the problem, it said the temperature was 25 Celsius, so we're going to go 298 Kelvin times the 15.42 joules per Kelvin mole. Okay. So when I do this, I'm going to multiply this out correctly first here. So this is going to give me 4,595.16, but I am going to convert it from joules to kilojoules. So this is going to be 4.595. Now our kelvins cancel. Okay. Now I have a negative value here, and I forgot to write my negative here, but this is going to be a plus right there. Okay, so negative 366.64 plus 4.595. So and that's going to give me a negative 362.05. Okay. Now, if you want to, you can take the delta G values and take delta G of the products minus delta G of the reactants and double check that and make sure you have the correct answer. Okay. So that is something that I would do when you get to the problem on the take-home exam. You're expected to find delta G, delta H, and delta S for something. Double check and make sure delta G equals delta H minus T delta S. Okay? And you will need these values in your book for that. All right. Where does K mole go? Okay, so notice this is joules per Kelvin mole, right? When I multiply Kelvin, and this is joules per Kelvin mole, the Kelvins cancel, this gives me joules per mole. I converted it, that would give me 4,595 joules per mole. I converted this to kilojoules by dividing by 1,000. Okay. And then I have another question on 26. Are we good with this one? I'm not going to, you guys can do B by yourself. Okay. All right. 26, we'll take a look at. Okay. So I'll take a look at 26. I don't know if I'll go through and work everything here. Okay, and your book likes to use a lot of terms like product favored or reactant favored, spontaneous reaction, product favored are synonyms. They mean the same thing as far as the book goes. And a reactant favored would be something that's not spontaneous. Okay. Taking a look at that. So we're looking at delta H and delta S for this reaction. Okay. So I think in this particular case, I'm going to go ahead and go through it all because I'm guessing A really isn't that difficult for you, but B is where you're having a little bit of trouble. So we'll take a look at that. So let's find delta H and delta S for that. It's not going to hurt to go through another sample here if we can do this fairly quickly. Tin oxide plus carbon solid. And that gives us tin solid plus CO2. Okay, so looking up delta H and S for these, I hopefully will get this right this time. But I need, let's see, carbon solid. I happen to be, well, I'm on the page for CO2 already. So delta H is negative 393.5. I'm going to round it off to the 10th. And that's going to be in kilojoules per mole. And in order to get carbon solid, I have to turn back a page because carbon is split between two. Now, it says carbon solid. If it doesn't say diamond, you need to assume that it's going to be the standard state, which is carbon, which is graphite. So our enthalpy is going to be 0. And our entropy, and I just realized I didn't write down the entropy for carbon dioxide. Our entropy here is 5.6. Very low entropy for a solid. Okay. Not the lowest there is. Diamond is actually much more ordered than that. CO2 gas, its entropy is 213.7. Again, our tin solid should be 0, and we'll verify that when we get to it. And that should be on the towards the last page. Tin, tin solid. We're going to go with white tin because it doesn't tell us anything about that. Okay. So that's 51.1 for the entropy for that. Again, if you want to round to the 10th, feel free to round to the 10th. It'll simplify things. And then if I look at the tin oxide, which is the bottom value here, so hopefully I won't mess this up. Its enthalpy of formation is negative 577.63. And its entropy is 49.04. Okay, so doing the calculation, delta G, actually we'll get to delta G here in a minute. So delta H, this is a little simpler because all the coefficients are 1, so I can just do negative 393.5. 5 minus negative 577.63. And then for delta S, it's going to be a little bit more. Again, I rounded everything to the 10th. Let me just do this to the 10th. We'll just call that 49.0. Just to make our calculations a little simpler. These number of significant figures here really isn't going to matter. So let's see. So this is going to give me 184.1 kilojoules per mole. Okay, so when I do the delta G is delta H. The delta H value is a positive. And again, 298 Kelvin. Times this is one of those where we can see that a delta G in this case is a positive value and the delta S is a positive value. Okay, so I will let you do the calculation to see if it's going to be spontaneous at room temperature. But I'll tell you now, if I increase this value enough, overall, this is going to be a negative delta G. So as you get to higher temperatures, delta G is going to be more and more negative. So it'll be more spontaneous as you go through, go into higher temperatures. And I think, okay. So I think it's now 10:49. So with that, hopefully this has helped you out a little bit. Again, the quiz on Friday is going to be multiple choice. At least one of them you will have to do a calculation with the values here, although I will not have you calculate delta H, delta S, and from that delta G all in one problem. If I expect you to calculate delta G from delta H and delta S for the reaction, I will give you those values. Be aware that's going to be one of those. All right? Okay. With that, everyone have a very wonderful April 1st. It's April Fool's Day. I haven't seen any April Fool's joke because with what's going on, everybody would believe it if I put anything out there. So we're skipping April Fool's joke this year, maybe. I don't know. My kids may be pulling some on. All right. And somebody asked how many questions are going to be on the quiz? Somewhere in the neighborhood of 10. Okay. So you should have about 2.5 minutes a question. I expect some people are going to finish in like 5 minutes and some people will barely finish in 35 minutes. That's just my guess. All right. With that, I will see you all on Friday. Have a good week. Just a reminder, next week is Holy Week, which means Friday is Good Friday of next week. So this week we have class on Friday. Next week we will not have class on Friday. We will not have class on Easter Monday. On Monday, I will start chapter 19. I will go through and post a PowerPoint to chapter 19 at some point. I will probably be doing 2 different ones. So with that, all right, have a good day.